In this video, I'll be proving Pythagorean's identity. So this video is strictly a proof video. It doesn't have any problems or anything. It's basically showing you where this identity comes from. So Pythagorean's identity is if you have sine squared of an angle and you plus the cosine squared of an angle, it will always equal to 1. Now this is true no matter what you're doing in math. This is not a formula, it's an identity. It's like an so identity means it's true no matter what. So for example, the quadratic formula, it's a formula specifically made for quadratic equations. You got the a coefficient, the b coefficient, the c coefficient, and it works for different spots in the formula. This here is an identity, so it works in any form of math. So no matter what you're doing in math, if you're dealing with trigonometry or any sort of angle stuff, this will always be true no matter what. But where did they get this from? Right, so the way they got this is basically they took a look at a thing called the unit circle. So if you hear the word unit in math, that means 1. So let's just take a look at just a circle on a Cartesian axis. So this is our x and this is our y. And we just have some, oh, that's a terrible circle. Let's see if I can do a good one. That's good enough. Alright, so the unit circle means it has a radius of 1. Okay, so this is 0, 1, and this is 1, 0. This is 0, negative 1, and this is negative 1, 0. Okay, so that's our unit circle. So let's make this a bit bigger because I've drawn it a bit too small. Alright, actually let's get rid of these little coordinates because we know it's a unit circle because I've got this little 1 here as the radius. So the way basically they found this is they basically took information from this unit circle and combined it with Pythagorean's theorem. Pythagorean's theorem is like a prerequisite to this, so they already proved Pythagorean's theorem before they proved Pythagorean's identity. So this is true by the time they tried to prove this identity here. If you want a proof of Pythagorean's theorem, I've got it on this channel. Just go search in the math playlist and you'll find it. So let's say, alright, so this is a circle. It's got a radius of 1. And let's say this is just some angle theta here, okay? What would this point be on the circle? Okay? So let's say it's just some x value here, some x length. Let's just call it x. So x is from here to here, and that's our x coordinate, alright? What would this be then? Well, it would be our y coordinate, wouldn't it? Because if you input an x value, you get a y coordinate on the unit circle. So this is the point x and y on pretty much any point on the circle. So just imagine you can rotate this point anywhere along the circle, pretty much, okay? Because this angle theta is arbitrary. I've just chosen it to be here for convenience sake. You could have chosen theta to be the angle all the way across here, but theta is just an arbitrary a symbol for any angle, pretty much. All right. Now let's take a look at our trigonometry rules. So we have SOHCAHTOA. So we have SOHCAHTOA. Right. I want to find an expression for this side length here in terms of the angle. So let's just take a look at what we have. So we have a hypotenuse of 1. So our hypotenuse is 1. Our adjacent is x. And so this is angle here. Opposite, adjacent, hypotenuse. And our opposite is y. Okay? So let's find an expression for the adjacent and the adjacent and opposite sides. So let's just take a look at the adjacent first. So we're going to look at cos. So cos theta is equal to the adjacent divided by the hypotenuse, right? We know the adjacent is x, so we can replace this whole thing here for x. And we know our hypotenuse is 1, so we can replace the hypotenuse here for 1. Anything divided by 1 is itself, so we can just rewrite this whole thing as cos theta equals x. So, knowing this, we can put that in replace for our side length there. So we're going to rub out our x now and put cos theta. Okay? And I'm going to rub this x out here and put cos theta. Hold up. Rub out this whole thing. So we have cos theta y. Alright? So see how we got rid of our x because we now have an expression for it in terms of the angle. So this side length here is cos of whatever angle this is, okay? Alright, let's find an expression for the opposite. So for the opposite, let's take a look at sine. So sine theta is equal to the opposite over the hypotenuse. We know the opposite is y, so we can just replace that opposite with y. And we know the hypotenuse is 1. Anything divided by its 1 is just itself, so the whole thing y is equal to sine theta. Cool, we've got another expression for this side length in terms of the angle. So we can replace the y now with just sine theta. So whatever this side length is, it's sine of whatever angle this is. Okay? And now we can replace this here with sine theta. So our coordinate, you can have it in terms of x and y, or you can have it in these things called polar coordinates, where it gives you an expression of pretty much just an angle and a trigonometric function. But let's take a look at, let's just draw out this triangle that we've established in here. So we have 1 as our hypotenuse. We have cos theta as our adjacent. And we have sine theta as our opposite. Okay, and this is a right angle, okay? No matter where this triangle is in the unit circle, it will always be a right angle triangle. What do we know about right angle triangles? Pythagorean's theorem, of course. So a squared plus b squared will always equal c squared. Okay? So let's apply this into that. So we're going to have cos squared theta plus sine squared theta is equal to 1 squared. Simplifying that, we're just going to have cos squared theta plus sine squared theta equals 1. And that is how they discovered Pythagorean's identity. So they combined trigonometry with Pythagorean's theorem and created Pythagorean's identity. And this is true everywhere in math, no matter what. This is never not true. It's an identity. Okay. I hope you enjoyed this video and learned something. If you didn't, just leave a comment where you got stuck. This is just a proof video. It's basically showing you where this identity comes from because it appears everywhere in math. But yeah. Alright. Thank you for watching.